My dear student, how are you? I think all of you are well, staying at home. Today I am going to conduct another class. So welcome to Amader Pathshala, presented by Manipur Uccha Vidyalaya and College. Our today's topics, Chapter 1, Thermodynamics. Lessons, Heat and Temperature. First law of thermodynamics, Physics 7 paper for class 11 and 12. Before going to our main discussion, let us know what we are going to learn at the end of our lecture, that is learning outcomes. At the end of the lecture, the student will be able to know the difference between heat and temperature. Know about the measurement of temperature, be able to know about thermal equilibrium, and last one, first law of thermodynamics and its application. So at the beginning of the lecture, I am going to tell you about thermodynamics. So what is thermodynamics? This is a new term for you. Thermo means heat and dynamics means motion. So thermodynamics is a branch of physics that basically deals with the movement of heat. So see the definition of thermodynamics in the slide. The branch of physics which deals with the relation of heat with energy and work is called thermodynamics. Thermodynamics basically deals with temperature, heat. So at first you have to be clear about what is the difference between heat and temperature. What is temperature? Temperature is the thermal state of a body which determines the direction of flow of heat when two or more bodies are in thermal contact with each other, and it also determines whether the body will absorb it or reject it. So let us see the definition in the slide. This is nothing but what I have told is given here. Now second one is heat. What is heat? Heat is a form of energy which makes sensation of hotness or coldness. So there is a far difference between heat and temperature. My dear student, sometimes you may merge with heat and temperature. You think both are same quantity, but this is not correct. The unit of heat is joule and the unit of temperature is temperature. Now, how can you measure the temperature of a body? In order to measure the temperature of a body, you have to take the help of others, and that is thermometric property. There are some substances which shows the thermometric property. So what is thermometric property? Thermo means again heat and metric means measurement. So thermometric property is a special type of property of the substance which changes uniformly with the change of temperature. Observing this specific property, temperature of the body can be measured. It's called thermometric property. So thermometric property may be the length of the body, maybe the resistance, or may the volume of the body. Now, only by knowing thermometric property you can measure the temperature of the body? No, it is not at all. You have to know some other quantities like the lower fixed point and the upper fixed point. So what is lower fixed point? At a standard pressure, the temperature at which water start to freezing or ice start to melt, that is melting point of ice is taken as the lower fixed point. You know that this temperature is 0 degree Celsius. Another one is upper fixed point. So what is upper fixed point? At a standard pressure, the temperature at which pure water start to vapor is known as the upper fixed point or the steam point. So this is the upper fixed point, you know that 100 degrees Celsius in Celsius scale, that is a steam point. So you just have learned what is thermometric property, what is lower fixed point, what is upper fixed point. By knowing this, you can construct a thermometer which helps to measure the temperature of the body. In order to measure the temperature of the body, you can make thermometer in two ways, by using one fixed point and another one is two fixed point. One fixed point, temperature scale based on one fixed point. What is meant by one fixed point? In 1954, an international conference held on the weights and the measures, from where the scientists taken the triple point of water as the fixed point, as one fixed point. And you know that what is triple point of water? Triple point of water, that means at a particular temperature at which water coexists in its three states. And there you know that this temperature is 273.16 Kelvin. So, by using thermometric property, you can make and using one fixed point, you can make a thermometer. You have to follow this. Suppose this is the thermometric property and this is the temperature. You know that this is the thermometric property of the thermometric substance used in a thermometer, and this is the temperature, and these two are directly related that with proportional relation. That means, if thermometric property increases, then temperature will increase. If thermometric property decreases, then temperature will be decreased. Then you can write mathematically x equals to A into T, where A is the constant of proportionality. Now, if we consider two temperatures, suppose one temperature is T1, another temperature is T2, for which the thermometric properties are x1 and x2 respectively. That means, x1, x2 are the thermometric property of the corresponding temperature T1 and T2, then what will be this equation? Simply mathematics, you can write this. This is the relation between two thermometric properties x1 and x2 with their corresponding temperature T1 and T2. If you consider one of these temperature is the triple point of water, considering its thermometric property, then what will be the equation? Let us see. If thermometric property at triple point of water is xTr, here suffix Tr indicates the triple point of water, and the thermometric property at any temperature is T is x. So, both are the thermometric properties xTr and x. X is only for T in a unknown temperature, and xTr is the thermometric property at triple point. So, these are the known temperature. Then the equation of this equation becomes T equals to T Tr x by xTr, where T is the triple point of water, and you know this, I have already said earlier, T equals to 273.16 Kelvin. So, this is the relation based on one point thermometer. In this case, if you know the x, that is thermometric property, and you know the thermometric property at triple point, then you can easily find out the unknown temperature. Here x is the thermometric property at temperature T, and xTr is the thermometric property at triple point, and x, you know that the thermometric property may be the resistance, volume, and something else. Now, finally, by solving a problem, I think it will be very clear to you. Suppose a problem available for you. The resistance of a resistance thermometer at triple point of water is 32.316 ohm, and its boiling point. What is the boiling point of a liquid if its resistance at its boiling point is 27.316 ohm? That means, what are the given information? Resistance at triple point of water 32.316 ohm, and resistance at boiling point R equals to 27.316 ohm. So, you have to find the boiling point T, that is the unknown temperature here T, and that is the boiling point. Now, very simple for you, if you see the solution, and you know that this is the solution, this is the required formula that we have learned in earlier. Here T and Tr, this is x and xTr. In this case, my dear student, the thermometric property is resistance. So, T equals to 273.16 R by RTr. Putting the value of R by RTr, you will get the temperature of the boiling point, and putting the value of R and RTR, that is the value of resistances at temperature, unknown temperature, and the triple point, you will get finally the boiling point T equals to 230.9 Kelvin. So, this is the boiling point of the given problem. That is all that we have discussed making thermometer for all fixed point. Now, I am going to discuss a thermometer based on two fixed point, and two fixed point, that means it contains a lower fixed point and the upper fixed point. My dear student, also I have told earlier. So, what is the difference between lower and upper fixed point? And you know that this is known as fundamental intervals, that is the interval between the lower fixed point and upper fixed point of a thermometer is called fundamental interval. The thermometric property of a steam point is x theta steam, x steam, and here the temperature is theta steam. That means steam theta denotes the temperature and x denotes the thermometric property at a steam point. And now, another quantity thermometric property, that is x ice as theta is. That means when temperature is ice, temperature theta is, then thermometric property is x ice, and when temperature is theta steam, then thermometric property is x steam. Now, we have to find establish the relation between the unknown temperature by using two fixed point. So, let us consider any temperature theta where the thermometric property of the body, a thermometric property is x theta, that is theta is unknown here, and where the thermometric property x theta is known to you. Then by using above three information, you can write in this way: x steam minus x ice proportional to 100 minus theta. You know that x steam is the thermometric property minus a thermometric property at ice is proportional to 100 degree, that is a steam point using Celsius scale, and this is the 0.0 degree Celsius, and these two are proportional using a thermometric property. You know that thermometric property is directly related to temperature. Now, mathematically you can write x steam minus x ice equals to k into 100, where k is the constant of proportionality. So, what will be above the unknown temperature for it? For unknown temperature, you can write x theta minus x I proportional to theta minus 0. This is the theta, unknown temperature, and this is the thermometric property at unknown temperature. Now, by using these two equation, this is the mathematical formation simply. So, by using 1 and equation 2, you will get the relation of a thermometer based on a fixed point temperature. Now, dividing equation 2 by 1, and you will get theta equals to x theta minus x ice, x steam minus x ice into 100 degree Celsius. So, this is the relation in order to determine the unknown temperature using two fixed point thermometer. In this case, all the properties I have already discussed. Now, if n is the fundamental interval of the equation, if n is the fundamental interval, then you can write theta equals to x theta minus x ice, x steam minus x ice into n, where n is the fundamental interval. In this case, we used the temperature in Celsius scale, that is why we have right here 100 degrees Celsius. So, this is the main equation for any unknown thermometer. Now, is another problem related to a thermometer and to double point or 2 point fixed. The resistance of resistance thermometer at 0 degree and 100 degree Celsius are 8 ohm and 20 ohm. That means 0 degree and 100 degree Celsius given resistances are, and if the thermometric is placed on the oven, then the resistance of the oven becomes 32 ohm. What is the temperature of the oven? That means these two thermometric properties are given to definite temperature, and another thermometric property for the unknown temperature is given, then you have to find the unknown temperature. Just simply use this formula, theta equals to r theta minus r naught, r100 minus r naught into 100 degrees Celsius, putting the value of r theta, that is 32, and r naught, that is 8 given here, and r100 is equals to 20. Putting all this value, you will get the temperature of the oven becomes 200 degrees Celsius. Now, my dear student, I have discussed thermometer on base of two fixed point. Firstly, we have discussed one fixed point, and second one we have discussed two fixed point. Between these two fixed point is very critical to meet. Now, I am going to discuss some different scale, international scale, which is basically built on two fixed point, and that is very clear to you. You know that this is the Celsius scale, lower fixed point, upper fixed point, and there is Fahrenheit scale, lower upper fixed point, lower fixed point, and the Kelvin scale, you know this. And so, what is the relation between these three scales? And that is C by 5 equals to F minus 30 by 9, K minus 273 by 5. These are the relation among these international scale you have already learned in class 9 or 10. So, you can solve any mathematical problem related to this formula. If a given temperature in Fahrenheit degree Celsius, then you have to calculate in Celsius scale by using this relation you have already learned in class 9. Now, some related terms related to thermodynamics. So, we are going basically we have learned thermodynamics, we have learned many things about thermodynamics based on temperature and heat, and now some terms related to thermodynamics. Number one is internal energy, the inherent energy of the system that can perform work and can be converted to another form of energy is called internal energy. Basically, internal energy is the combination of the potential energy and the kinetic energy. The more the kinetic and the potential energy, the more the internal energy. Number one is thermal, number two is thermal equilibrium. Thermal equilibrium means if two or more bodies are in thermal contact with each other, suppose this is body A and this is body B, and if these two bodies are in thermal contact, equilibrium, then nobody can heat absorb or gain loss heat or absorb heat. That means body A will not loss heat or gain heat from B. This is the thermal equilibrium. So, just see a figure. This is three cylinder, you are seeing that. In this case A, B and C, these three container or cylinder are in thermal equilibrium, because A in thermal equilibrium with B and B with thermal equilibrium with C. That means these three, among these three, they do not exchange any heat or energy. So, these are the thermal equilibrium. In this case, if A and C are separately in thermal equilibrium with B, then A and C are also will be in thermal equilibrium. I repeat it, if A and C are in thermal equilibrium with B, that means A and C are also mutually in thermal equilibrium. So, this is known as the zeroth law of thermodynamics. Now, thermodynamic system, another definition related to thermodynamics. Thermodynamic system, the particular portion of the material world which we consider to perform an experiment is known as thermodynamic system. That means, from material world we take some portion separately to conduct an experiment, this is known as system. And thermodynamic coordinates, these are the coordinates of the variables. Due to the variation of any one of these quantities, the thermodynamic system may be affected, and so these are known as the thermodynamic coordinates. That means, the variable or the coordinates for which thermodynamic system may be changed due to change of this. And now, thermodynamic process. Any change of thermodynamic coordinates of a system is called thermodynamic process. That means, we have already done thermodynamic coordinates, temperature, pressure and volume. If any one of these is changed, then what will be the change of the system? This will be discussed in thermodynamic process. Thermodynamic process like the isothermal process, adiabatic process, isobaric process, etc. In isothermal process, you know that the temperature remain constant, and the adiabatic process there is no exchange of heat from interior to exterior, and isobaric where the pressure remain constant. So, these are the thermodynamic process. Now, first law of thermodynamics, we have learned some terms related to thermodynamics. Now, first law of thermodynamics. Before this, just a figure. This is the well known figure, this is the steam engine, you know that. In this figure, the water is converted to steam by applying heat, and the steam basically runs the turbine, which basically produce electricity, and this is a process where heat energy is converted to mechanical energy. This is the steam energy, that is heat energy or thermal energy, and converted to mechanical energy. This is the mechanical energy or the work done W, and this is the thermal energy H. These two will be proportional to each other according to first law of thermodynamics, W proportional to H, where work done and heat are proportional to each other. So, by using mathematical equivalent, W equals to H. So, this is the mathematical formula of the first law of thermodynamics. So, what basically the first law says? If heat energy is converted to work, or work is converted to heat, then these two will be proportional to each other. This basically described here. So, what is G here? J here. J is the mechanical equivalent of heat, simply known as Joule constant. If H equals to 1, that is H equals to 1 unit, then W equals to J. So, J is the work done, J is the work done, J is the mechanical equivalent of heat for which it produces. The amount of work done to produce unit heat, it was known as mechanical equivalent of heat. To produce unit heat, the amount of work that we have to done is known as mechanical equivalent of heat. In this case, if we write J in H in heat in SI unit, then J will be in 1, that is work done and heat both are in Joule. In this case, J will be 1. So, now another formula, another theorem about first law of thermodynamics. This is a system, the system is considered as a cylinder that contains an ideal gas with a movable piston. So, if you supply some amount of heat dq on this system along this way, then you will see that the internal energy of the gas will be increased by du, internal energy, and then do some external work, that is dW. And if you perform this accurately, then you will see that they follow this relation, that is del Q equals to del U plus del W. So, this is the first law of thermodynamics. So, what will be the first law of thermodynamics according to Clausius theorem? Basically, if you apply some amount of heat in the system, then the portion of the heat is used to increase the internal energy of the system, and the rest amount of heat is used to do some external work. So, this is the first law of thermodynamics on basis of Clausius theorem. Basically, first law of thermodynamics says the principle of conservation of energy. Now, for the case of very small sense, you can write dq in place of del q. So, dq equals to du plus dw. So, this is the work done and this is the change of internal energy, this is the supply heat or rejected heat. So, when dq will be positive or when du will be positive or dw will be positive, that will be very clear by seeing a table. In this table, you will see that dq, when heat is absorbed by the system, then dq will be positive. Similarly, when the system lost heat, then dq will be negative. And when the internal energy will be increased, du will be increased, that is positive, and internal energy losses, then du will be negative, and work done by the system, then dw will be positive, and work done on the system, then dw will be negative. So, this last point is very important for you, I think, to solve mathematical problems and to give its explanation. Now, I am going to illustrate what will be the value of dw. Work done by expanding gas, but I am going to discuss the expansion of gas in isobaric process. Isobaric process. This is a cylinder. This contains some amount of gas where the pressure of the gas is P and fitted with a frictional piston having area A. As you know that if the pressure of the gas P, so what will be the pressure? P equals to, you know that F by A, then force F equals to PA. So, this is the force. So, the gas applies force on the piston is PA, and now the work done. Suppose the gas expand from a small displacement dx, my dear student, here only mention d, that basically this will be dx, and then work done will be f into dx, and you know that f equals to pa. So pa dx, and a dx is the change in volume, then you have write dw equals to p into dv. So this is the work done. Then equation 1 becomes dq equals to du plus p dv. So this is the equation of first law of thermodynamics. Now if the gas is changes its volume from V2 beyond to V2 beyond to V2, then what will be the work? Simply by calculating integration you can find W equals to P into V2 minus V1. So this is the work done. You can write this way by using ideal gas law. You know that PV equals to nRT, where n is the number of mole. So this is the same equation for different form. Now finally you will get the first law of thermodynamics is this. Now do some mathematical problems. This is a mathematical problem for you. In this case, this is a constant pressure Pa. That means some amount of gas is enclosed in a cylinder fitted with a piston, keeping the pressure fixed 600 Pascal, and 125 joule heat is supplied to the system, for which the volume of the gas changes from 2.5 to 3.75 meter cube. That means at constant pressure you have supplied some amount of it where the changes of volume take place, and now you have to calculate the work done and change of internal energy. So what are the given information? These are the given information. This is the constant pressure 600 Pascal, and dq is the supply heat, initial volume, this is the final volume. You have to calculate work done and internal energy. Just used first law of thermodynamics. First law of thermodynamics, this is the work done, you have already learned. Putting the value of P, V2 and V1, you will get dW, that is the work done. Similar way, you can write du equals to dq plus dw. This is the first law of thermodynamics, you know that, just rearranging, and for our needed du equals to dq minus dw, putting the value of dq and 125 and dw 750, you will get du equals to 625. So this is the change in internal energy. In this case, du is negative. So a question for you: work done by the system here or work done on the system here. Now just have reached the end of the class. So a simple homework for you, and this is a system. You know that working substance is taken from A to B, B to C, and again C to A. So what are the properties here? In this case, this internal energy is 0, and in this case internal energy is 25 joule. When B to C, you have to, it has to do 40 joule work or needed 40 joule energy. You have to calculate some mathematical problems. Number 1, what is thermodynamic properties, that you have learned. Number 2, mechanical equivalent, we have already done. And this problem is internal energy, you have to calculate at C point. And D, is it possible to determine what amount of heat the body will absorb, or is it when it returns A to C? So simple problem for you, try your best to do the problem. So no more today. Thank you all to join with us.